discuss the importance of being able to graph equations. And what is that, really? Well, here's an equation. Y equals 1/2 x. We're going to learn how to graph that today, but first I want to talk about what it means to graph an equation. 1/2 x is 1/2 times x. Multiplication is the same as how many of something. So you can also think of it as y equals 1/2 of x. Well, the graph is a visual display of all the ordered pairs that satisfy this equation. For example, if you look at my little table over here, let's say x is 10. Well, y is half of x, so y would be 5. Or if x was 4, so y would be 2 for that x. If x is 1/2, y is half of that, so it would be 1/4. This table helps you collect some points that you can graph to get part of the visual display. And we don't need a million points, we just need a few to sketch in what the graph is. So let's give it a try. I'm going to back up a step and pick some points a little more thoughtfully. You can actually plug in any numbers for x that you want to in this table of values that we're going to graph. I like to pick a few integers and some fractions. Any other numbers you think will fit on your graph. If you pick large numbers, you get to see what happens, but they may not fit on a piece of paper. So when x is 0, what's half of 0? Well, it's still 0, isn't it? When x is 1, half of 1 is 1/2. How about when x is -1? Okay, that's 1/2 times -1, which is -1/2. And we talked about half times a half, or half of a half, just a minute ago. That's 1/4. And 1/2 of 2 is 1. 1/2 of 3 is 1.5. Now that gives us a few points. Each of these is actually now an ordered pair that you can display on a graph. So let's draw a graph. A two-dimensional graph is simply two number lines. One of them represents x values. Okay, this number line will represent our y values. Positive numbers go in this direction for x and in this direction for y. And that's about how big I'm going to make my scale. I'm not using the graph paper because it is too tiny to be useful. So negative numbers are going to go in the other direction. So for y, that's going to be in that direction, and for x, that'll be in that direction. Okay, let's graph some of these points. So we have 0, 0 on our graph, and we have 1, 1/2. I'm going to estimate that 1/2 is right about there. -1, -1/2. So now I'm going to go backwards on the x-axis to -1 and estimate about halfway. So that would be right about here. 1/2, 1/4 is over about halfway, and up only 1/4, which is not much at all. Okay, and 2, 1 over 2, up 1, right about there. Okay, and 3, 1.5. And as you can see, this is starting to form a pattern. All of these points seem to line up on a diagonal line right here. We don't see any points way out here, for example. And if you do, that's a red flag that you've probably made an arithmetic error over in your table. Let's connect them, and I'll tell you why we can do this in just a moment. If we were to plug in more and more points, they would fall right on this line. And if you just kept going and going and going, imagine plugging in hundreds of points. Eventually, they would fill in the space between these points and make this line. I put arrows at both ends to show that I realize that this goes on and on and on. This is just a little piece. And it is also nice to label your graph, y equals 1/2 x. And that is how you make a visual display of an equation. And over here, this is our table of values. Let's use both of those for another equation. Here's y equals 2x minus 3. Every y value on the graph is 3 less than 2 times every x value. So let's pick a few. And I always like to try a fraction just to see if anything interesting happens when you plug in something that is not an integer. So when x is 0, that means we're looking at 2 times 0 minus 3. Be sure you follow the order of operations here. So that's 0 minus 3, which is -3. When x is 1, we have 2 times 1 minus 3. That's -1. If we plug in 2, we get 2 times 2, which is 4. Minus 3 is 1. -1, so that is -2 minus 3, which is -5. And -2 times 2 is -4, minus 3 is -7. 2 times 1/2 minus 3. 1 minus 3, which is negative 2. And let's see what this looks like. 0 is right here on the x-axis, and I need to establish my scale. 1, negative 1 would be over 1 and down 1. 2, 1 would be over 2 and up 1. And at this point, you can kind of check and say, hey, are these lining up? We don't have any points out in space. Negative 1, negative 5, then negative 2, negative 7 there. And 1/2 negative 2 there. Okay, and those line up pretty nice. And you have the visual display. Let's look at one more. So this one's a little different. In this equation, it's important to follow the order of operations. So we're going to do the exponent part first, calculate that before you multiply by 1/2. When x is 0, we're going to do 0 squared, and then 1/2 of that. 1/2 of 0 is 0. When x is 1, we're doing 1/2 of 1, which is 1/2. When x is 2, then x squared is 4, 1/2 of 4 is 2. And when x is negative 1, negative 1 squared is positive 1. So this is 1/2 of 1, which is positive 1/2. When x is negative 2, x squared is 4, 1/2 of 4 is 2. X is 1/2, 1/2 squared is 1/4. 1/2 times 1/4 is 1/8. Okay, let's try graphing this and see what happens here. So we've got a point at 0, 0, and 1, 1/2, 2, 2, negative 1, 1/2. I'm going to go backwards 1 and estimate about halfway up right there. And negative 2, positive 2, 1/2. This is interesting because this is not a straight line clearly, but it is a pattern. Let's see if 1/2, 1/8 fits into it. So we estimate over 1/2. Up 1/8 is just going to be barely up at all. Okay, and that does seem to fit into it. But let's continue our table just a little bit more to get a clearer picture of what's going on with this one since it's turning out different. We can try negative 1/2, and how about 3 and negative 3 also, just to expand it a little bit. So if x was negative 1/2, when we square it, it's positive 1/4. So again, we'd have 1/2 times 1/4, which is still 1/8. When x is 3, x squared is 9. Half of 9 is 4.5. When x is negative 3, x squared is 9 again. Half of 9, still 4.5. So this is a symmetric graph. When we plug in positives and negatives, we're getting the same y values for them. At 3, we are up 4.5, and same with negative 3. So what this is a curve, more like a U, but a U that gets wider and wider and wider and wider. But that's approximately what the graph looks like, and all the points are falling into that pattern. This technique works for graphing any equations that are of this form, y equals something involving an x. Now that you know that, you should be able to do a lot more homework problems. Enjoy that, and let me know if you need any more help. Good luck.